When the head of Indonesia's volcanology agency briefed officials on Sunday morning, the language he used was unusual for a man who normally speaks in careful percentages. He didn't talk about probabilities. He talked about a pattern he hadn't seen in years, a volcano in the country's remote northeast that had been erupting every single day for 47 consecutive days, and the numbers underneath that streak that were, in his word, accelerating. 47 days. That's not a single eruption event you can point to on a calendar, draw a circle around, and file away. That is a continuous, unbroken run of volcanic activity, stretching from one month into the next, with no sign of a natural pause. And what makes this particular streak genuinely alarming? Not alarming in the sensational sense, but alarming in the way that volcanologists quietly use that word when they're reviewing data at 2 in the morning, is that it keeps intensifying. Each week of those 47 days has produced more ash, more sulfur dioxide flux, and more seismic energy than the week before. The anomaly isn't just that it hasn't stopped, it's that it keeps getting louder. Now, factor in the human geography. Within a 12-kilometer radius of Dukono's active crater, the PVMBG, Indonesia's Pusat Vulkanologi dan Mitigasi Bencana Geologi, the agency responsible for monitoring every one of the country's 127 active volcanoes, has mapped a resident population of 105,134 people. That's not a projection. That's a census-derived count. 155,134 individual human beings living, farming, working, and raising families in the zone that scientists currently define as the primary hazard radius. And the question that nobody in that briefing room could fully answer, the question that's been hovering over every monitoring report coming out of northern Maluku for the past 6 weeks, is this. Is what we're seeing right now the established baseline of one of the world's most persistently active volcanoes, or is it something genuinely new? That distinction matters enormously, and it's what we're going to spend the next 25 minutes trying to understand. Let's start with geography, because most people, even people who follow volcanic activity closely, have only a vague sense of where Halmahera Island actually is, and that vagueness undersells just how complicated the human situation here really is. Halmahera is the largest island in Indonesia's North Maluku province, and it sits in a part of the Indonesian archipelago that doesn't get much attention in international news. It's shaped roughly like a 4-pronged starfish, a landmass so irregular that it looks like a piece torn from a larger puzzle. The island covers about 18,000 square kilometers, roughly the size of Slovenia. And it occupies a zone where the Pacific Plate, the Australian Plate, and the Eurasian Plate all interact in a tectonic collision that geologists describe as one of the most geometrically complex subduction environments on Earth. Dukono sits on the northern peninsula of that island, at an elevation of approximately 1,087 meters above sea level, overlooking a coastline that faces the Sulawesi Sea to the west and the Pacific Ocean to the north. The nearest substantial town is Galela, sitting roughly 8 kilometers from the volcano's summit. So close that residents there can see the ash column on clear days, without any optical aid whatsoever. The larger administrative center of Tebelo lies about 35 kilometers to the south. And then there's Ternate, the provincial capital, about 200 kilometers southwest across open water. A city of over 200,000 people that has historically felt the reach of volcanic events from across the Maluku region. None of these communities are distant from this situation. They're embedded in it. Here's something that helps put the regional context into perspective. When Krakatoa erupted catastrophically in 1883, killing an estimated 36,000 people through pyroclastic flows and the tsunamis they triggered, it ejected ash across an area stretching more than 500 kilometers from the source, and the resulting cloud circled the globe and lowered average temperatures for the following year. Krakatoa is roughly 2,000 kilometers southwest of Dukono. That comparison isn't meant to suggest equivalence. Dukono is operating at a fundamentally different level, but it illustrates something important about how volcanic ash behaves in this part of the world. The Indonesian archipelago sits in a corridor of persistent equatorial winds that can carry fine particulate matter extraordinary distances with very little warning. Tambora, whose 1815 eruption remains the most powerful in recorded human history, sits about 800 kilometers south of Dukono and generated ashfall that darkened skies across the entire region for months. Dukono isn't Tambora, but the atmospheric highway that connected Tambora to the wider world runs directly over northern Maluku. That's not a theoretical concern. It's a documented meteorological fact that VAAC Darwin, the Volcanic Ash Advisory Center responsible for the airspace above this region, monitors continuously because the flight corridors connecting Manila to Darwin and Davao to Singapore pass within the potential reach of any significant escalation from this volcano. So when we say 134 people are locked inside the hazard radius, we need to understand that number doesn't capture the full population potentially affected by what Dukono could do if this 47-day escalation continues to build. But we'll get to the future scenarios. First, let's talk about what's actually happening inside that mountain, because Dukono's geology is both fascinating and, once you understand it properly, genuinely sobering. Dukono has been in a state of more or less continuous eruption since 1933. Let that sink in for a moment. Since 1933. That's over 90 years of essentially unbroken eruptive activity, which puts it in a very small category of volcanoes worldwide that volcanologists classify as persistently active rather than cyclically active. Stromboli in Italy is the most famous member of that club. Kilauea in Hawaii earned that designation for decades. Dukono is the Indonesian representative, and the Smithsonian Institution's Global Volcanism Program, which maintains the most comprehensive database of volcanic activity on Earth, has logged Dukono as one of the longest continuously active volcanoes in its entire dataset. What does that continuous activity actually mean at a mechanical level? Think of Dukono's magma plumbing system the way you'd think about a river that never fully dries up, but varies enormously in its flow rate. In drought years, that river is a trickle, technically still moving, still connected to its source, but barely. In flood years, it becomes something that reshapes the landscape around it. Dukono's plumbing has never gone dry since 1933. The question volcanologists are asking right now is whether they're watching the river move from a persistent trickle towards something with genuinely flood-level energy behind it. The eruption style is predominantly Vulcanian and Strombolian, two classifications that tell you a great deal about the character of the activity. Strombolian eruptions, named for Stromboli itself, are characterized by regular, relatively small explosions, generated by bursts of gas breaking through a magma surface that's partially cooled and crusted over. They're dramatic to watch. Ballistic bombs, incandescent fragments, rhythmic blasts, but they're generally confined in their reach. Vulcanian eruptions are a step up. They involve the rapid, violent expulsion of gas-rich magma from a vent that's been partially sealed, creating much taller eruption columns and significantly more ashfall than the Strombolian style alone. Dukono's andesitic magma composition is critical to understanding why it behaves this way. Andesite, named for the Andes where it's particularly common, is a silica-rich volcanic rock that produces viscous, sticky magma. Unlike the fluid basaltic magma that powers Hawaii's relatively gentle, effusive eruptions, andesitic magma traps gases inside it as it rises. Those gases build pressure as they're unable to escape gradually. The result is the explosive, gas-driven blast-style characteristic of Vulcanian events. And when that gas content is particularly high, as PVMBG data suggests it's been during this 47-day escalation, the eruption columns get taller, the ash gets finer and travels farther, and the sulfur dioxide flux increases measurably. The PVMBG's monitoring network around Dukono has recorded SO2 flux readings during this escalation period that are running approximately 40% higher than the baseline measurements recorded across the same calendar period in 2023. 40% in roughly 47 days compared to what was already an elevated baseline, which is more than double the SO2 output measured during comparable periods in the 5 years prior. That's not noise in the data. The Smithsonian GVP has been flagging Dukono in its weekly volcanic activity reports with increasing frequency over this period, noting both the duration of the continuous activity and the elevated gas measurements as distinguishing features of what we're currently watching. The ash column heights tell a similar story. PVMBG reports during the escalation window have documented columns reaching consistently between 1,500 and 2,000 meters above the summit. That's between 2,500 and 3,000 meters above sea level, with individual event peaks pushing toward 3,000 meters above the crater on at least 6 separate occasions in the past 3 weeks. For reference, the standard PVMBG baseline for Dukono's normal persistent activity is columns in the range of 500 to 800 meters above the summit. We're currently seeing columns 2 to 4 times that height on a regular basis. The Magma Indonesia app, the public-facing monitoring platform that PVMBG operates and that anyone can download, shows real-time status updates for Dukono. If you've pulled it up in the past week, you've seen the volcanic activity status sitting at a level that the agency's own descriptive language characterizes as increased activity above normal. That's bureaucratic language, but read it carefully. Above normal. And at Dukono, normal already includes nearly continuous low-level eruption. So, above normal at this volcano means something qualitatively different than above normal would mean at a volcano that's quiet between its eruptive episodes. The seismic picture is consistent with what the gas and ash data are showing. PVMBG seismometers around the northern Halmahera region have been recording elevated tremor signatures, continuous low-frequency vibration associated with fluid movement inside volcanic conduits, at levels that indicate a robust, well-established pathway between the magma source and the surface vents. When that pathway is wide open and actively fed, the tremor is steady and sustained rather than sporadic. Right now, it's sustained. University of Indonesia researchers collaborating with PVMBG on regional volcanic monitoring have noted in recent communications that the tremor character at Dukono over the past 6 weeks is consistent with a system that has increased its magma supply rate, not merely maintained its existing rate at higher surface expression. But here's what makes Dukono's situation genuinely difficult to assess with confidence. The volcano's chronic activity is its own kind of camouflage. Because it's always doing something, it's harder to identify the inflection point where doing something more becomes doing something fundamentally different. That's one of the central challenges PVMBG scientists are grappling with right now. And it's a challenge with a documented historical precedent. That history starts with the formal baseline, when PVMBG, or rather its predecessor agency, since Indonesia's volcanological monitoring apparatus has evolved considerably over the decades, established the 1933 eruption as Dukono's modern baseline. They were documenting the beginning of what has become one of the world's longest uninterrupted eruptive sequences. The 1933 event itself was a significant escalation from prior activity, characterized by the opening of new vents and the establishment of the persistent fuming and occasional explosive behavior that has continued in some form ever since. The event that stands as the most significant departure from the chronic baseline is 1978. That year, Dukono produced what volcanologists classify as a sub-Plinian eruption, a step change in intensity that falls between the ordinary volcanian character of its normal activity and the full Plinian column-forming eruptions that marked the most violent volcanic events in the geological record. A sub-Plinian event at Dukono in 1978 generated an ash column estimated at between 8 and 12 kilometers in height, reaching well into the stratosphere, and deposited significant ash across a wide area of northern Maluku. The PVMBG archives document disruption to agricultural activity across multiple districts of Halmahera, and reports of ashfall reaching communities on neighboring islands. That 1978 event is the data point that sits at the back of every volcanologist's mind when they're reviewing the current escalation reports, because it demonstrates what Dukono is physically capable of when its system moves out of its chronic low-intensity mode. The 2019 through 2024 period has seen a progressive pattern of elevated activity that's been documented in both PVMBG bulletins and the Smithsonian GVP's weekly reports. In 2019, Dukono produced a series of eruptions with columns exceeding 2,000 sound meters above the crater, notable at the time, but interpreted as within the range of normal variability for a chronically active system. By 2021, the frequency of high column events had increased, and SO2 measurements were trending upward. 2023 saw the first extended run of elevated activity, lasting more than 2 weeks continuously. At the time, the longest such run in the recent observational record. Now we're at 47 days and counting. The trajectory isn't a straight line, but the direction it's moving in is not ambiguous. For context, consider what Indonesia experienced with Sinabung in Sumatra. That volcano had been dormant for 4 centuries before reactivating in 2010, then produced a slow build escalation across several years. By 2013 and 2014, it was generating pyroclastic flows that killed residents, who had returned to evacuated zones during a period of apparent quiet. The lesson Sinabung taught Indonesian volcanology, a lesson PVMBG has incorporated into its operational protocols, is that chronic escalation patterns can mask the transition to genuinely dangerous eruptive phases until that transition is already underway. Soputan, on the island of Sulawesi, roughly 600 kilometers west of Dukono, provides another instructive regional comparison. Soputan is also a chronically active and acidic stratovolcano, and in 2018 it produced an eruption column exceeding 6,000 meters that disrupted regional air traffic and required precautionary evacuations of surrounding communities. Before that 2018 event, Soputan had been in a pattern of elevated but manageable activity for several months. The escalation, when it came, moved faster than the surrounding communities had anticipated. And then there's Merapi, Java's most famous and most carefully monitored volcano, which demonstrated in its 2010 eruption. One of the deadliest volcanic events Indonesia has experienced in recent decades, that even with sophisticated monitoring and established evacuation protocols, the gap between elevated activity and catastrophic eruption can close with alarming speed. Standing in a classroom in Galela on a Tuesday morning in the 3rd week of this eruption sequence, you're a school teacher. There's a thin gray haze across the sky that wasn't there last month, and the air carries a faintly acidic quality that makes your throat feel slightly raw by midday. You've been issued masks, the kind that filter fine particulate matter, and you're distributing them to your students. You're not panicking. Nobody in Galela is panicking. But every day that haze persists, every day the ash settles on the corrugated rooftops and vegetable gardens, the question you keep not asking out loud grows a little harder to ignore. That's the lived reality underneath the monitoring data. 155,000 people navigating daily life in the shadow of a volcano that is, right now, doing more than it normally does. The monitoring infrastructure in place around Dukono is real, it's professional, and it's better than what existed during the 1978 sub-Plinian event, but it has documented constraints that matter enormously for the question of whether 105,134 people can be adequately protected if this escalation continues to build. PVMBG operates a network of seismometers positioned around Dukono's flanks, coupled with visual observation posts that provide real-time data to the agency's Galela Observatory. The observatory itself, one of PVMBG's regional monitoring stations, is staffed by scientists who are reviewing volcanic tremor data, tilt measurements from GPS-coupled deformation sensors, and thermal imaging from satellite passes around the clock. The Magma Indonesia platform synthesizes this data into the public-facing alert system that communities, local government officials, and emergency response agencies use to calibrate their preparedness. But here's the complicating reality. The head of the PVMBG Observatory in Galela has been candid in communications with local government officials about the infrastructure gaps that would complicate a large-scale evacuation of the communities closest to Dukono's crater. The road network connecting Galela and the villages on the northern Halmahera Peninsula to the safer southern parts of the island is limited. There are no highways here. There are provincial roads, some of them unpaved for significant stretches, that represent the only ground-based evacuation routes for communities sitting inside the current hazard zone. If those roads become impassable, due to ashfall accumulation, lahars on the volcano's flanks during rain, or simply the volume of vehicles attempting simultaneous evacuation, the logistics of moving 155,134 people quickly become extraordinarily complicated. VAAC Darwin, the Volcanic Ash Advisory Center, responsible for the flight information regions covering this part of Indonesia, has been issuing regular advisories for Dukono throughout this escalation. Aviation color codes have been elevated during periods of high column activity, with ash cloud altitude and drift direction documented for aircraft operators on the Manila-Darwin and Davao-Singapore corridors. A color code of red, indicating ash at altitudes that directly threaten commercial aviation, has been triggered multiple times during the 47-day sequence, each requiring coordinated communication between VAAC Darwin, Indonesian Air Traffic Control, and individual airline operators. The PVMBG alert level for Dukono is currently at level 2, waspada, meaning alert or caution. The second of 4 levels, above the baseline level 1, normal, and below level 3, siaga, standby, and level 4, awas gasins, danger, which triggers mandatory evacuation orders. The current waspada designation places the exclusion zone at 2 kilometers from the active crater. That sounds significant, but consider that Galela itself is 8 kilometers from the summit. The buffer between the official exclusion zone boundary and the nearest substantial population is 6 kilometers. If activity escalates to siaga, that exclusion zone expands. If it reaches awas, evacuation becomes mandatory. Scientists cannot predict exactly when or whether this system will move to the next alert level. That's not a failure of monitoring. It's a fundamental feature of volcanic systems that even the most sophisticated observational networks can't eliminate. What PVMBG scientists can say with confidence is that the current trajectory of the data, the SO2 flux, the ash column heights, the seismic tremor character, is pointing in a direction that warrants sustained, serious attention. So what could happen if this escalation continues? The modeling that PVMBG and its academic research partners have developed for Dukono's potential scenarios is instructive, and it's worth walking through carefully, with the AMESICI explicit acknowledgement that these are conditional projections, not forecasts. If Dukono's current escalation were to progress to a Volcanic Explosivity Index Level 3 event, a VEI3, which would represent a significant step up from its current activity and would be comparable in scale to the lower end of what was documented in 1978, the immediate impacts could be severe and wide-ranging. A VEI3 eruption at Dukono could generate an ash column of 10 kilometers or more, pushing well into the stratosphere. At that altitude, the equatorial jet stream could carry fine ash particles westward toward Sulawesi and eastward toward the northern Philippines within 48 to 72 hours. The Manila Flight Corridor, one of the busiest in Southeast Asia, handling hundreds of flights per day between the Philippines and destinations across Asia and Australia, could face significant disruption if ash at stratospheric altitudes drifts into that airspace. Davao's Francisco Bangoy International Airport, serving the Philippines' third largest city, sits approximately 700 kilometers from Dukono and has historically been affected by ash events from Indonesian volcanoes further away than this. The agricultural impact on northern Maluku's farming communities could be significant even at VEI3 levels. Halmahéra's agricultural base, coconut cultivation, clove farming, and subsistence food crop production would face ash deposition capable of damaging or destroying current season crops across thousands of hectares. Clove trees, representing a significant part of northern Maluku's economy and requiring years to reach productive maturity, are particularly vulnerable to sustained ashfall. A VEI3 event occurring during Indonesia's rainy season, which runs roughly from November through March, could trigger lahar formation on Dukono's flanks. Lahars are volcanic mudflows generated when water, whether from rain or the melting of any volcanic snow or ice deposits, mixes with loose ash and pyroclastic material on steep slopes. They move fast, they follow river valleys, and they can reach communities far from the crater that might consider themselves outside the primary hazard zone. The health dimension deserves particular attention because it's often underestimated in the early stages of volcanic escalation. Volcanic ash is not simply dirty air. It contains fine silica particles. Some of them of respirable size, meaning they can penetrate deep into lung tissue, along with sulfuric acid droplets formed from the SO2 in the eruption plume. Extended exposure to volcanic ash at the concentrations that communities within the hazard radius experience during periods of elevated activity carries documented risks for respiratory health, particularly for children, the elderly, and those with pre-existing respiratory conditions. If activity were to escalate to VEI3 levels and persist for an extended period, the cumulative health burden on 155 134 people living within the primary hazard radius could represent a public health crisis that outlasts the acute eruptive phase by months or years. The USGS, which maintains collaborative research relationships with PVMBG, has documented how chronic to acute eruption transitions at andesitic stratovolcanoes in island arc settings produce health outcomes that strain regional medical infrastructure. In northern Maluku, that infrastructure is already limited relative to population need in non-emergency conditions. That asymmetry matters. What should you take away from all of this? 47 days of continuous, escalating volcanic activity at a volcano with a documented history of sub-Plinian capability. With 134 people in its hazard radius, no highway evacuation network, and a 2-kilometer exclusion zone that hasn't widened despite the elevated data, warrants serious, sustained public attention. Not panic, not catastrophizing, the kind of grounded attention that asks the right questions about monitoring resources, evacuation infrastructure, and respiratory health supplies before those questions become urgent under emergency conditions. Researchers continue to study whether what we're watching at Dukono represents a true threshold shift in the volcano's behavior or an unusually extended episode within its established parameters. That scientific uncertainty isn't reassuring, but it's honest. And honesty is what 150,134 people living in a volcanic hazard zone deserve from the people who are paid to understand what's happening beneath their feet. The PVMBG scientists in Galela are doing their jobs. VAAC Darwin is doing its job. The Magma Indonesia platform is providing public access to real-time data. But awareness matters too. Not awareness as a substitute for institutional action, but awareness as the thing that keeps institutional attention focused on situations that might otherwise get quietly deprioritized because they're geographically remote and economically marginal by global standards. Northern Halmahera is not a major media market. Galela doesn't have a large international press corps. The communities inside Dukono's hazard radius are, in many ways, dependent on people outside that radius caring enough to keep asking questions. And there are more questions to ask. Indonesia's network of 127 active volcanoes faces monitoring challenges that extend far beyond northern Halmahera. Systems closer to major population centers and critical international aviation corridors that deserve their own careful scrutiny. The Sulawesi Sea alone sits above tectonic structures capable of producing events that would dwarf anything Dukono is currently doing. The northern Philippines, the Kamchatka Peninsula, the Cascades, the Ring of Fire is an active, continuous geological system that generates new threats on timescales shorter than human institutional memory. Drop a comment below. Tell us what volcanic system you want us to cover next, and share this video with someone who lives in a region that has active volcanoes nearby and might not know the basics of what to look for, what to monitor, and what the alert levels in their country actually mean. That kind of practical geological literacy isn't just interesting. It's the kind of knowledge that saves lives. Subscribe if you want to stay informed as this situation develops, because we'll be watching the PVMBG bulletins, the Smithsonian GVP weekly reports, and the VAAC Darwin advisories closely. This story isn't over, and 47 days in, the data suggests it's just getting started.